Hello guys, how are you doing? One last time, I want to take you through gradients and equations of a straight line. Today, the focus will be on the equation which was brought in 2022 KCSE. There is one thing you're going to learn from this question, or there is something you'll come to appreciate from this question. If you are the kind of student who avoids or does not give much focus on definition of terms, this question was bound to give you a problem. Reason being, this question required a student who had a thorough understanding of the topic and well conversant with definition of terms, which many students decide to ignore in mathematics. Today you'll appreciate that it is really important to understand those definitions. Let's get started. What was the question? A triangle. So the question is talking about a triangle. A triangle ABC is right angled at point A. The first thing I expect from a student is to have already formed a picture at the back of his or her mind. Take note, the question is talking about a triangle, and this triangle is right angled. At which point, a triangle ABC is right angled at point A. Even before we continue reading, how about we come up with a diagram of how the triangle could be looking like? So let's have this. Let's have this as our triangle. So this is our triangle A, B, C. One thing that the student has to be keen on is the right angle must be specifically at A. That is because the question was very specific on that. A triangle ABC is right angled, at which point the triangle is right angled at point A. So if the student had to sketch a diagram, let it come out clearly that the right angle is at A and not at any other point. So what do? Let's proceed. The vertices of the triangle are A is 1, -2. Our B is 5, 4. And our C is M, N. So A is 1, -2. The B is 5, 4. And the C is M, N. What are you told? Determine the equation of line AC in the form of AX plus BY plus C is equals to 0. Let's not focus on this one here first. Let's start by focusing on how will we obtain the equation of line AC. Then this will come to be sorted a little bit later. So how do we obtain the equation of line AC? If you have been following our videos, I defined perpendicular lines at some point as lines meeting at a right angle, or if you like, lines meeting at an angle of 90 degrees. On that note, I won't have done anything wrong if we say that line AB and line AC are perpendicular to each other. But in the question, there is nowhere in particular where the word perpendicular was used. This is what we call an application question, and the student is required to rely on definition of terms in order to answer this question. Do take note, in this question, there is nowhere the question mentioned that AB and AC are perpendicular. But you also need to take note that the question was very specific that our triangle is a right angled triangle, which is to mean there is an angle of 90 degrees at point A. Therefore, AB and AC are described as perpendicular lines, though the question did not use that word directly. So please do take note, because you have said that AB and AC are perpendicular, then we expect that gradient 1 times gradient 2 should give me a product of negative 1. M1 times M2 should give us negative 1. That is what happens whenever two lines are perpendicular. So let's start by obtaining the gradient of AB. We will start by finding the gradient of AB. But why AB? It is possible to find the gradient of AB because I have both coordinates of A and B, making it possible to obtain the gradient of AB. So we will start by obtaining the gradient of line AB. How then will we do it? Let's label this one here as our x1 and this one as y1. This will become our x2 and this will become our y2. How do you find gradient? y2 minus y1 all over x2 minus x1. What is our y2 in this case? Negative 2 minus y1, which in this case is positive 4. I will put this one here over x2, which is 1, minus x1, which is 5 in this case. So this will be negative 6 for the numerator and negative 4 for the denominator. The two negatives will cancel out, giving us a gradient of 3 over 2 when simplified. That should mean line AB is having a gradient of 3 over 2. We have already agreed that AB and AC are perpendicular, which is to mean that if AB is having a gradient of 3 over 2, then line AC should have a gradient of negative 2 over 3. If you've been following our lessons, I gave you a good shortcut of getting the other gradient without going into a lot of trouble. Once we have the gradient of AB as 3 over 2, then a line perpendicular to it should have a gradient which is an exact opposite of what you already have. So if AB is having a gradient of 3 over 2, then AC is expected to have a gradient of negative 2 over 3. When I talk about opposite, I also mean the two numbers will be interchanged, or you pick what I call the reciprocal. How then will we find the equation of AC? Do not forget that we were asked to determine the equation of line AC. Do not forget the focus is on line AC. We want to obtain the equation of line AC. How will that be achieved? We know already that the gradient of AC, just to repeat, will be the opposite of what I'm having here. So if line AB had a gradient of 3 over 2, then line AC will have a gradient of negative 2 over 3. An exact opposite of what we have there. If you have your calculator, please confirm if this times this will give us a product of negative 1. Please confirm if it gives you a product of negative 1. I suppose it is giving you negative 1. How then will we find the gradient of AC? Not the gradient, but the equation of AC. We will pick the point A, which is 1, negative 2, accompanied by a pair of variables x, y. We will then use it to obtain the equation. This will be y2 minus y1, which is again negative 2. I will put this one here over x minus 1 is equals to a gradient of negative 2 over 3. We already know that two negatives will always make up a positive, which I'll put all over x minus 1 is equal to negative 2 all over 3. We will then cross multiply. So what will we have? 3 will be multiplied by y plus 2. Then negative 2 we will multiply by x minus 1. 3 times y would give me 3y. 3 times 2 would give me 6. Negative 2 times x will give me negative 2x. Then a negative times a negative should give us a positive. Then what do we do next? The question gave us an order in which our answer was supposed to be presented. The question said the answer must come in the form of ax plus by is equal to c. That is to mean that which carries x should come first. In this case, it is the negative 2x. I will carry it over to this other side. The rules of maths are, if a negative number will cross the equal sign, it becomes a positive. So I'll be having positive 2x. Followed closely by by, which is to mean that which is carrying y should follow. So I will follow it with 3y. Then the c is supposed to be coming last, which is to mean I will transfer the 2 to this other side. So that we'll be having plus 6 minus 2 is equals to 0. So what will this one be? This will be 2x plus 3y plus 4 is equals to 0. And this becomes the answer for the part A, Roman 1. It is asking for the equation of the line AC in this form. That is the equation. This one now takes us to the part B. What do we have in the part B? In the, not part B, but part A, Roman 2. In the part A, Roman 2, you are being asked to obtain the coordinate of point C. You are required to find the coordinate of point C. How do we obtain the coordinate of C? Take note. In the question, it was mentioned somewhere that the equation of line BC is this. So we have got the equation of the line BC. As for AC, we have found it for ourselves here. How then will we get the coordinate of C? First and foremost, what is C? C is what we call a point of intersection of line BC and AC. Do remember, we defined a point of intersection as a point where two or more lines meet. And you'll agree with me that C is the point where line BC and line AC are meeting. Therefore, C is what we call a point of intersection, which implies that if we must obtain the coordinate of point C, then a student will be required to look for C as a point of intersection. How will that be done? We will solve this equation and this equation simultaneously. That is the reason why I said this is an application question. And a student is required to be very smart when it comes to application skills. The coordinate of C is basically a point of intersection, but the question did not use those words as some of the students may expect. So this is what we have. To find the C, we will take this equation and this other equation, then solve them simultaneously. Reason being, by looking for a point C, we are basically looking for a point of intersection. We are looking for a point of intersection. What is the equation of line BC? The equation is 5y, that was given here. The equation of line BC is 5y minus x is equals to 15. That is the equation of line BC. What is the equation of line AC? That one we got for ourselves. It was 2x plus 3y plus 4 is equals to 0. But I want us to start with the y for purposes of orderliness. So I will start with the 3y, after which the 2x will follow. Then as for the 4, let's take it to the other side of the equal sign. Being a positive, it will now become a negative. What then will you do? The two equations will be solved simultaneously. How? Take this equation, multiply by 3, and this other one, multiply by 5. 3 times 5y should give us 15y. 3 times x should give us 3x. And 3 times 15 should give us 45. 5 times 3y should give me 15y. 5 times 2x should give us 10x. And 5 times negative 4 should give us negative 20. These two equations will then be subtracted. 15y minus 15y should give me 0. You can as well cancel the 2. Negative 3x minus 10x should give us negative 13x. Confirm that with your calculator. Then 45 minus 20 should give me positive 65. Confirm that with your calculator as well. We'll divide this by negative 13, this by negative 13. The value of x, therefore, will become negative 5. How then will we look for the value of y? This value of x will be substituted either in this equation or this equation. Allow me to go for the first one. This is 5y minus x, which is negative 5, is equal to 15. This will be 5y. Two negatives should make up a positive, is equals to 15. The 5 will cross over to the other side of the equal sign so as to become a negative. So what is 15 minus 5? That should give us 10. Divided by 5, divided by 5. The value of the y will be 2. Therefore, what will be the coordinate of C? Do you remember I said C is referred to as a point of intersection of line BC and AC because it is a point where the two lines are meeting. So what is the coordinate of C? The x coordinate will be negative 5 and the y coordinate will be positive 2. This is the answer for part A, Roman 2. Which will now bring us to the last question. Which now takes us to the last question. We have got the part B. What do we have in the part B? A line passes through point A and is parallel to line BC. Where is the line BC? Do you remember this was our line BC? 5y minus x is equal to 15. A student is required to start by obtaining the gradient. How will that be done? This equation should be represented in the form of y is equal to mx plus c. To achieve that, the x will be taken to the other side of the equal sign to become a positive x plus 15. Divide this by 5, this one by 5, and this one by 5. What do we get? Y equals 1 over 5 of x plus 3. What will the gradient become therefore? The gradient will become 1 over 5. But because the question said that this line is parallel to the line BC, what do we know about parallel lines? Parallel lines will always have equal gradients. That is to say, if line BC is having a gradient of 1 over 5, then the line we are talking about should also have the same gradient of 1 over 5. We were also told somewhere that this line passes through point A. What is the coordinate of point A? The coordinate of point A is 1, negative 2. So we'll take the point 1, negative 2, accompanied by a pair of variables xy. We will then obtain the equation y minus negative 2, which I'll put over x minus 1 is equal to a gradient of 1 over 5. This will then become y plus 2 over x minus 1 is equal to 1 all over 5. So how do we find the equation? We will then cross multiply. This 5 will be multiplied by y plus 2 equals the 1 will be multiplied by x minus 1. 5 times y, 5y, 5 times 2 should give us 10 equals 1 times x will give us x, 1 times negative 1 would give us negative 1. The 10 will then cross over to the other side, giving us 5y is equals to x minus 1 minus 10. This will be 5y is equals to x minus 11. That does not answer the question. The question did not ask us to obtain the equation, no. We were asked to obtain the x-intercept of the line. How then will we get the x-intercept? We already know that at x-intercept, the value of y will always be equal to 0. At x-intercept, the value of y should always be equal to 0. So as I begin the journey of looking for the x-intercept, there is one thing I already know. The y coordinate should be 0. So we are in a business of only looking for the x coordinates. What do? I will take the equation. In the place of y, we will substitute 0 is equal to x minus 11. What's 5 times 0? That should give us 0 is equal to x minus 11. The 11 will then cross over to this other side to become a positive. Therefore, the x will be 11. Our x-intercept, therefore, will be 11, 0. That will be the x-intercept of the line. The x-intercept of the line. Thank you. Have a good time. Please do remember to practice. The two questions you can think of practicing with is the 2018 question and the 2019 question. They are good questions that will involve a deep thinking. Have a good time.